Hey everybody, welcome back. Today 6.5, we're going to be talking about trapezoids. We do have a couple of theorems and vocab words, but today we are going to be focusing, all of that is going to be focusing on trapezoids. So we're going to be using different properties of trapezoids. Alright, so what I want you to do is I want you to please write this down and I will come back and we will talk about it. All right, so if you look at a trapezoid is a quadrilateral with exactly one pair of parallel sides. It says each of the parallel sides are called the base. The non-parallel sides are called the legs. Base angles of a trapezoid are two consecutive angles whose common side is a base. So your top and your bottom are always going to be parallel. I shouldn't say just your top and your bottom. You're going to have one set of parallel sides. So if we look at this is a normal shape for a trapezoid. Okay, but these are always going to be parallel. You're going to have one side that is always parallel, or one pair of sides that are always parallel in a trapezoid. Those are going to be called your base. Okay, awesome. Next, it says if the legs of a trapezoid are congruent, the trapezoid is an isosceles trapezoid. The following theorems state the properties of an isosceles trapezoid. You don't have to write that second sentence down. Okay, so if you look at an isosceles trapezoid, you will notice that it looks similar to this shape. Okay, where we know that a trapezoid has to have one pair of parallel sides, and then your legs are going to be congruent. Okay, so if you have your legs congruent and you have your parallel sides congruent, then, if you have your legs congruent and one pair of parallel sides, then you have an isosceles trapezoid. We have a couple of properties that go along with isosceles trapezoids. Here we go. Alright, so the very first one, it says if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So if you look at this diagram and this example here, you will notice that B and C, because it's an isosceles trapezoid, B and C have to be congruent to each other. Same thing with angle A and angle D in this very first theorem. Alright, and what makes an isosceles trapezoid? Well, you need to have a trapezoid, which tells you that you have one pair of sides congruent, and then one pair of sides parallel, not congruent, parallel. And then you're on a trapezoid. If you have two legs that are congruent, then you have an isosceles trapezoid. All right. Next one, 664. It says if a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. Okay, so if you look at this, notice that just your base angles here have to be congruent. If those are congruent, then it's an isosceles trapezoid. All right, you will know this when you have two sets of base angles. So you need to have A and D congruent, or what's your other two sets of base angles? You could also know if B and C were congruent. So either one of those, they are going to be, it is going to be a trapezoid. All right. Last one, if a trapezoid is isosceles, if and only if its diagonals are congruent. So if you have two diagonals that go across, remember, to its non-consecutive point, then you will have an isosceles trapezoid. Okay, if AC is equal to BD. All right, that's the last of the theorems you have. Okay, we're going to try a problem. All right, so it says ABCD is an isosceles trapezoid. Find the missing angles. All right, so you have three angles that I want you to find. So find those three angles and figure it out. Give her a shot. All right, so we know that if an isosceles, if a trapezoid is isosceles, then both pairs of base angles are going to be congruent. So that tells me that angle A is going to be equal to angle B, and angle C is going to be equal to angle D. All right? So right off the bat, we already know what one measure is going to be. We know what angle D is. Okay? We know that angle D is going to be equal to 100 degrees. How do we know that? Well, angle C is 100 degrees, and angle D is equal to angle C. Okay? So, finish that one. Now we have B and A. We know that both of them are going to be equal to each other, meaning they are the exact same measure. We also know from a previous lesson, I believe 6.1, that all of quadrilaterals have an angle, that quadrilateral angles theorem, interior angles theorem. What do we know? What is that quadrilateral angles theorem? Interior angles theorem? It means that angle A plus angle B plus angle C plus angle D is going to be equal to 360. All right? So now that that's equal to 360, now we plug in what we know. What's angle A? We don't know. It's going to be X plus, what's angle B? We don't know. It's going to be X. What's angle C and D? They're both 100, and it's going to equal 360. So now we have 2x plus 200 is equal to 360. Subtract both sides. We have 2x is equal to 160. Divide by 2. X is going to be 80 degrees. So what does that tell me? That tells me both A and B are 80 degrees because we know they're both exactly the same. So angle B is equal to 80 degrees. Angle A is equal to 80 degrees. Okay, going back from previous theorems that we know, that quadrilateral angles or interior angles theorem, we can add them all up to equal 360. Another one we could do, if you looked at this measure or this trapezoid, notice C and B. What relationship would C and B have to each other? What do you think from previous lessons? They're alternate interior, or sorry, same side interior angles, right? They're same side interior angles, which means you would know right there that they would add up to equal 180 degrees, which would tell you B is equal to 80 degrees, which in turn would tell you A. Okay, so there's different theorems you can use. Choose the one that's going to be best for you. All right, moving on. Now, what this states, it says it is a mid-segment of a trapezoid. So the mid-segment of a trapezoid is the segment whose endpoints are the midpoints of the legs. Okay, so if you look at those legs, all right, this, if we said that A, B, C, D, E, F, AB is going to be congruent to BC. DE is congruent to EF. And the only thing that makes that possible is that mid-segment that goes straight across. It becomes the midpoint of the legs, both midpoints of the legs, and it's a segment that connects them. Okay, it connects those two ends. Here's the theorem that goes along with it. It says the mid-segment of a trapezoid is parallel to each base, and its legs is 1/2 the sum of the lengths of the bases. In other words, that mid-segment is equal to half of the two bases added together. Okay, if you look at this segment, this theorem, you will notice that XY is your mid-segment. BC and AD, those are your legs. Okay. We add those two together, cut it in half, and that's going to be your XY. Another way to put this is XY is equal to BC plus AD all over 2. Add up the two bases, divide by 2, that's your mid segment. All right, so let me show you one, and then I'm going to have you do another one, and then we're done for the day. A couple more slides. All right, so here we go. So here is a problem. It says find EF. You're finding line segment EF. So in this, we know the formula for finding the mid-segment of a theorem. And EF is that mid-segment. How do you know it's a mid-segment? Well, we know that point E is the midpoint of AB because AE is congruent to EB. We know that point F is going to be the midpoint of DC because DF is congruent to CF. Okay, and with that EF connected, okay, that being the segment, we know that that's the mid segment. Okay, so now we are looking for EF. Well, we know, according to our formula, that our mid segment, EF, is going to be equal to half of the two bases added together. So we know that it's half of AD plus EC. So now that it's half, we are going to take EF is equal to half, or dividing by 2, 13.5, which is AD, plus 8, which is BC. Whoops, we are not having AC up here. We have BC up here. My mistake. And then we're going to take 13.5 plus 8 divided by 2. Okay, so when you take all of that, you have EF is equal to 21.5. Divide that by 2, and you will come up with EF is going to equal 10.75. All right, so now we found EF. We added our two bases together, which was AD and BC, divide it by 2, and we get our mid-segment. Awesome. This one we are going to write down. All right, now we know what the mid-segment is. We have to find one of the bases. So pause now, and I want you to try to see if you can find this one out. All right, so again, you know what the formula is. You know that xy, you know that xy is going to equal FG plus EH all divided by 2. Okay, plug in the information you know. XY is equal to 16.5. FG is equal to 25. We have no idea what EH is, and we're going to divide that by 2. All right, from here, how do I solve for EH? Well, I need to get rid of this 2 on bottom. So multiply by 2, multiply by 2. And I now have 33 is equal to 25 plus EH. Subtract 25 on each side. And EH is going to equal 8. Okay? You're always going to have one base that's larger than the mid-segment. You're always going to have one base smaller than the mid-segment. That mid-segment should be right in between both of them. Okay, right in between them. So if you look at 8, EH is 8. We know that in order to get from EH to XY, you have 8.5 here. And in order to get from XY to FG, you have another 8.5 here. That's going to be the exact same. Okay, it's going to be in the middle. All right, so we are done for today. I hope you enjoyed trapezoids, mid-segments, and everything that goes along with it. Isosceles trapezoids. Now you are so much smarter on trapezoids. I know it. I hope you enjoyed. Awesome. Have a good day.